Evening, everyone, from a very late night in London. My name is Adam Bennett. I'm an Android engineer at a company called Cuvva. Just to give you a tiny bit of context, we sell temporary car insurance by the hour. So that may give you some context as to some of the code clips you might see, which mention list of vehicles and that kind of thing. The topic for this evening is error handling in Kotlin, and specifically the result monad, which is something that we've adopted at Cuvva to great success. So what I'm going to go through this evening. Why errors in Kotlin are a tricky problem to solve, what specific issues we were having at Cuvva, and what we're trying to solve there, why we chose the result monad in the end, and then how we integrated it, but also lessons that we learned along the way. So I'm going to try to impart a little bit of hard-earned knowledge, I guess, from things that we discovered from integrating this particular style of working. This does build on top of an article that I wrote a few weeks ago, specifically about the result monad. I'm not going to go into too much depth into the API or kind of how it works in this particular talk. I wanted to offer more kind of practical advice. But if you are kind of wanting for more detail, or if you're confused by anything or that kind of thing, definitely check out the link at the top. That'll take you directly to the article, or head to my website, adambennett.dev, and you'll be able to find it's the most recent one. So please do check that out if anything, basically if you want any more detail. So cool. Exceptions. When we think of exceptions, we tend to think of unexpected problems. But there is another type of exception that we deal with all the time. And exceptions are a perfectly valid type of our control flow and our domain logic. And basically, there's many places where exceptions are perfectly expected forms of operation. And so some examples of this are going to be things like network requests. Obviously, on a mobile device in particular, you might have a flaky connection. You might have to surface things like I/O exceptions, things like security issues, SSL issues, or timeouts and that kind of thing. Loading a file that a user selected. We might show an intent picker. We might say choose a file, but the app may not be able to handle it. And we want to be able to handle that specific case. We probably don't want to crash the app when a user chooses a PDF and we can't read it. Just a standard part of domain logic, say selecting an item which is out of stock or invalid or something, we're going to want to surface this to the user. We're not just going to straight throw. So ultimately, in this type of situation, we want to be able to model this where possible, rather than just using the kind of try-catch construct that we're all very, very familiar with from Java, I would assume. If we go on to Kotlin exceptions themselves, so Kotlin is a little bit different from Java in that it has unchecked exceptions. This means that your compiler isn't going to give you any hints as to whether a function can throw or not. Any consumers of your API must check the method signature, and what you'd expect to find is the throws annotation, but this isn't required. It's actually something which allows much better Java interop if you expect your Kotlin library to be called from Java, and it's not required at all. And this means that we can't necessarily rely on consumers handling our calls appropriately and handling failure states appropriately, because they simply may not realize. So that was one problem that we wanted to avoid. If we look at this, this is a very typical use case that you might see. So a suspending function, and when we invoke it, we fetch a list of vehicles. In this case, we've done a try-catch, and because the type that we're returning is a non-nullable list, we return an empty list. And this is, I think we can all appreciate this is probably a pretty poor API as a consumer. An empty list is a perfectly valid type of response for a fetch vehicle list. And the caller has absolutely no idea whether that's a valid state or a failure state. Could we improve this? We could make it nullable. We could return null in the failure state. You could argue this is a better API for consumers, but they ultimately have absolutely no idea what caused the issue. And if you want to surface specific errors, this just kind of doesn't really work. It's very ambiguous. What we could do is we could just push dealing with this issue onto the caller. So we could not handle the try catch ourselves and tell anyone consuming the API to handle it. This is also not great. Like I said, the caller may not realize, the compiler won't tell you. And because this annotation is optional, you could have not included it, and then the caller would be really none the wiser. So we wanted to look at a way of solving these sorts of issues, and our list of sort of requirements for Dream API was we wanted to be able to wrap exceptions which we know are likely to fail, so that we don't have to do this whole try-catch construct. We wanted to be able to model both success and failure types more succinctly, and specifically we wanted them to have different types. So we didn't want to return things like nulls, we didn't want to return empty objects, because that's not a great API to consume. And we wanted to be able to map the success and error types independently as we cross boundaries between the data layer, the domain layer, and the presentation layer. So when you're working in the data layer, when you're working close to the network, having exceptions is perfectly fine. In the domain layer, you may want something which is more meaningful to you. And in the presentation layer, you're probably going to want something like a display string, so the user has some indication of what's happened. We want to be able to chain these operations, ideally. We want to be able to compose these operations together, and we want to short circuit on failure. So if something fails, we don't want to then attempt to do everything else as well. We just like to stop the execution there. And in this, we would like to be able to make it absolutely clear to a consumer what to expect when they consume our API. But we also want to give them some flexibility to consume it how they see fit, how they best want to. Lastly, a big requirement for us, it needs to integrate well with flow and coroutines. We decided to work on kind of the bleeding edge, and a lot of our architecture is based on flows. And something that would integrate there would be really important for us. And I'll kind of go into more detail about that a little bit later and show you kind of how our architecture works in that respect. So the solution we ultimately chose was the result monad, which is explicitly for modeling both success and failure states. An alternative that we could have chosen is the either, which I think a lot of people will be somewhat familiar with, where you generally have a left type and a right type, which are independent. But it's somewhat ambiguous if you're not used to functional programming. Is the left type the value type, or is the right type? And some languages have conventions, but it's not enforced. And some libraries will even have a function to swap those values in case you're used to one type compared to another, if you want to switch them. And we wanted to avoid that. Another option we could have looked at as well as an optional, but you could potentially argue that nullable types within Kotlin are a form of optional anyway, and that wouldn't really solve our requirement of being able to surface what the exact cause of the error is. So the result monad, it satisfies all the requirements that we wanted. It is our kind of dream API. And we ended up deciding on a library called Kotlin-result. This is just because it was the most comprehensive one that we could find. It was the best tested, best maintained. And it also borrows a lot of ideas and a lot of its API surface from languages like Scala, Rust, Haskell, and Elm, which means it uses a lot of conventions that are very familiar to functional programmers. We didn't want any kind of library that reinvents the wheel or tries to be maybe slightly more Kotlin-y. We wanted it to be more kind of idiomatic, I guess. You can find it here, Michael Ball /Kotlin-result, and credit to Michael and the maintainers for creating such a fantastic library. It's really become a core part of our architecture now. So to very briefly touch on the API for people who aren't familiar, Here we create a success type. It happens to be called an OK, and this encapsulates the hello world string. We can use a destructuring declaration here, which is fantastic, and we can access both the value and the error types. And in this instance, because it's an OK, because it's a success type, the value is equal to hello world, and the error is null. Makes sense. Carrying on with this very simple example. So here we're able to transform the value. What we do here is we drop the first value, which just knocks the exclamation mark off the end, and then we map to the length of the string, and then we multiply that length. It's a really simple example, but it just shows that you're able to transform this value, but also change its type completely arbitrarily, which is something that we really wanted to be able to do. Similarly with an error, so here we've captured a throwable. We can map that to just recover the message if we want to. We've arbitrarily decided to take the length of the string as well. And again, this just shows that you can map error types. So you aren't just bound to using something which extends throwable. Your error type can be whatever you like. And this is a big reason why we didn't use the standard library Kotlin result. Also here you can see that there's an explicit map error function rather than using a fairly ambiguous map left or map right. And we decided that this was quite important for people who are less familiar with functional programming. It's just a bit of a clearer API, basically. Lovely. So when we decided that this is the way we wanted to go, we started integrating it in a very narrow scope. And luckily our app is incredibly well modularized. And that meant we could just convert across a small section of the app. And like I said, network requests are a really good place for using this kind of construct. And we did this simply with the run catching lambda. And all this does is it invokes the function that you wrap, and then it does the whole try catch dance for you. And based on whether it's successful, it creates an OK with the underlying type. And if it's an error, it creates an error with throwable type. If you were being really fancy, you could build yourself a retrofit network adapter, which would handle this type for you. We admittedly haven't got around to doing that yet. When we do, we will probably open source it. I think there's probably a fair bit of interest in this being made available. But like I said, we haven't got around to doing this yet. So once we were comfortable with that and comfortable that it worked the way we expected, we started doing some slightly more complex stuff. And so here's an example of a typical kind of interaction that you might be able to do using this kind of construct. So we have a suspending function here. It calls a bunch of other suspending functions. But what we're able to do here is we call the auth service to get a token. And then immediately after, we want to be able to map to a specific auth error. So if your initial auth step fails, you probably want to inform everyone. Once you hit this error, it short circuits the chain, and obviously everything below this is no longer executed. However, if that call is successful, we can then chain together other result types. And so here we simply fetch a list of vehicles using the token that we've already retrieved from getToken, and then getPolicies relies on that as well. And so this chaining, or what's called monadic comprehension, is a really neat, really easy way to work and combine what can be quite complex operations together, whilst avoiding the kind of callback hell, which I think a lot of people are very familiar with. Here as well, we're able to map to a domain type and map the error to a domain type as well. So our ultimate return type is a policy domain, and our error type is a domain error. And then it means when we create our use cases, because of the return type, it's very, very clear what the author intended here. This is a function which has a failure state, and there's really no ambiguity about that. However, it's entirely up to you how you manage this on the caller side, and you're not really pigeonholed into any developer's design decisions when you consume this. So if we look in a view model, for instance, just happens to be how we use this. If we don't care that the result might be nullable, we can use nullable type and we can just naively get it. If we do care about that, then what we can do is provide some kind of fallback, in this case an empty object if we want to. But typically you'll be doing something like this, where you'll be launching a suspending function which has been wrapped. You'll map to a presentation type, map to an error type, and then on success and on failure, you're able to invoke these side effects, which for us might be updating live data, for instance, and which is then exposed to the view. In the Curva Codebase specifically, we do things a little differently. The right-hand side, where we have repositories that coordinate network, disk, cache, and use cases that then use that repository. We use coroutines there for everything, and more recently we've used results for everything as well. So everything is a suspending function which returns some kind of result. On the left-hand side, though, we do something a little bit different. So this is entirely flow-based, and what we've done is we've built a unidirectional architecture based on Kotlin Flow, where we take inputs from a user. These are then acted upon in the view model, which might consume use cases, and based on the result of those use cases, we then emit events which are then rendered onto the UI. And so there's this kind of boundary between all the kind of domain, businessy logic, and the data side and the UI. And it looks a little bit like this. So what we did is we created this type called a flow transformer. This is shamelessly stolen from RxJava. And all it does is it is a function which takes an upstream flow and allows you to map it to a different type altogether by returning another flow. I'll go into this in a little bit more detail in a little bit. But ultimately, flatmap latest, it's a suspending function, and that means that we can happily invoke our coroutines which return results within this context. So here we emit a loading object, and a lot of people have asked me how you manage loading states when you switch across to using something like a result monad. And ultimately, we made a decision that the use cases and the repository and that kind of thing, it's not really their business to know about loading states. It's really a UI problem. And so we move that responsibility to the UI. I know that Google recommend using a resource sealed class, which is in many ways very similar to a result monad, but without the kind of comprehensions and the chaining. But we decided to go a slightly different route. And so this is how we handle that specifically. So we get the policies in here. And then we invoke this fold function. And what fold does is it basically unwraps the final value. So the return type now is no longer a result. It is a type that you choose. And so success and failure both have to return a one type. And in this case, it returns an update object. Based on whether it's successful or failure, we return a success or an error type. And then this is immediately emitted. Emitted to our UI and then rendered. This style of working, where we kind of have this clear separation, where we switch from the coroutine domain-based, coroutine-based domain sort of layer to the flow-based UI layer, has really, really worked well for us. Obviously, within these functions, we can take advantage of the flexibility of these monads, map types as we please, and then emit an object that the UI recognizes. And this sort of flow transformer interface is very easy to test individual chunks of logic that build up your view model. And we're really enjoying using it, basically. What we're going to do is, this is part of a wider MVI framework that we're going to open source in the next few months, I think. There's been a fair amount of interest in it because it's relatively unusual. It's not tied to Kotlin result, so you can choose to handle your logic however you want within these flow transformers. But when the timing's right, once some of the Flow APIs become a touch more stable, we'll probably release this into the wider world. So yeah, is that it? Is that problem solved? Sadly, it's not. So there's some lessons that we learned, and just going to go over a few of these. Ultimately, we've really enjoyed using the result monad, and it's really made intentions clear. It's allowed us to move really quickly and really safely, which is fantastic. But it is not a silver bullet. If there was such a thing as a silver bullet, we'd all be using it, and there'd be far fewer tech talks because there'd be far fewer opinions out there. You still have to remember to wrap APIs that might fail, and you get no help here. So you just have to be diligent about that kind of thing. So it doesn't solve every type of exception, for instance. What it's great for is for modeling expected control flow. So when you are likely to experience an error for one reason or another, and you want to make it clear to the user what the error is, then this is what you want to use. It's not for wrapping everything. There's definitely going to be cases where some types of exception must remain exceptional, basically. If your app is capable, if your app gets into an unexpected state, you're still going to want to throw. You're not going to want to wrap this. If you wrap everything, it's going to get very confusing very rapidly, and your app's going to get into all kinds of weird states. You don't really want to do that. One example of this is for things like file operations. You might be tempted to simply wrap every file operation in a result monad. But say you need to load a config for your app from a file, which the app expects to be able to run, and then that fails, you probably immediately want to crash the app. You don't want to allow the user to continue. So this is a case where you absolutely wouldn't use it. In terms of consuming, so we tend to consume this within flows. It just tends to be how we like to use this API. But in general, I would recommend avoiding using flows or indeed RxJava with result as a return type. And this is ultimately because it can get quite complex if you combine them regularly. If you can imagine having, say, multiple Kotlin flows that return results that rely on each other, if you have to then flat map them in sequence, you've just got this extra unwrapping step, and it can make things very hard to parse. So I would avoid doing that personally. We do it in a couple of places, but that tends to be where we know we're not going to be combining multiple steps. And yeah, so there's definitely some reasons where you may not want to do this at all. And one situation where, which I've discussed already, is basically situations where you want to fail fast. If the app is capable of getting into an invalid state in some way or another, you're going to want to throw. And if ultimately you're using a result monad to model exceptions, and then it can get to a state where you then want to throw anyway, it's kind of pointless. You might as well just live with the exception. So there's definitely cases where you want to fail fast, and then it's not designed for that. Local exceptions are a perfectly valid use case for normal exceptions as well. If the control flow is complex and it's private to say to a function, it's absolutely fine to use normal exceptions. For example, if you're, say, passing a tree for specific information and you don't find it when you expect to, it's okay to throw and then exit early, and then maybe catch that one level further up. That's perfectly valid. You don't want to use a result for that kind of thing, because it's just going to complicate things. Particularly if the return type of your function isn't a result, you don't want to create them inside a function just for the sake of being able to handle an exception. Just throw in that case, it's absolutely fine. Apathy. Ultimately, if nobody cares what caused the error, or it's not going to be consumed, it's best to avoid doing this. You might as well just return a nullable type, use an optional, that kind of thing. As I've said, don't try to model every I/O operation. Certainly things like network calls, it makes a ton of sense, but you're not going to want to wrap every single file operation, for instance. Performance, this is likely to be less of an issue on Android, for instance, but if you're running really, really tight loops and performance is absolutely critical, this is an extra allocation. Every map is an extra allocation as well, so you probably want to avoid that. And public APIs, if you care about interop at all, then you probably don't want to force callers or consumers of your API to understand what a result monad is. It's not particularly fair. It's not a great API to have to, basically, if it's forced upon you, you don't really want that. It's absolutely fine within a team. If you've decided within a team that you want to use this kind of functional error handling, that's great. But for a public API, you really don't want to do this necessarily. Lastly, a more kind of human reason, functional programming is kind of scary. I think everybody here probably remembers the really steep learning curve when RxJava first came out, and it took a really long time to master. And ultimately, you know, RxJava borrows a lot of these sort of functional concepts. The API should be very familiar. But if you're onboarding someone who's more used to the imperative world, it's going to be a really steep learning curve. So just bear that in mind as well. So logging is also a really, really good one. It is really easy if you're just wrapping everything to just end up swallowing these exceptions without any kind of logging. And failures with no logs are really not fun to debug. You will absolutely hate yourself if you have to dig through every single layer of your architecture to figure out exactly where the problem arose because you didn't log a stack trace. So that's something to bear in mind. The solution to this is not to just pass that stack trace up in a domain object. At that point, you might as well just throw an exception. It's a bit pointless. So don't do this either. Is a really simple solution to the logging problem is something like this, run catching and log, where we do the normal run catching, let the result monad handle this result for us. And then on failure, we just invoke a side effect, which in this case is printing a stack trace. Super simple, but it prevents you from ending up in a situation where the app is failing and you've absolutely no idea why. You may want to pass your own logger implementation, that kind of thing. One other advantage of this as well is, unfortunately, the Kotlin standard library has a function which is extremely similar called run catching, and you're likely going to import the wrong one all the time. So creating your own function with a slightly different name is quite a nice way to avoid that as well, because it drives me mad regularly. And lastly, a little pro tip, to make use of type aliases. So you'll write things like this all the time, where you have a type T, but the error type is going to be a throwable. It's definitely not a bad idea to create, say, an API result type alias where you get to omit throwable bit. Just saves you a little bit of typing and maybe makes it even more clear. Similarly, if you've ignored my flow and result advice, you may end up with this diamondy generic nightmare. If you're going to use this kind of thing all the time, again, maybe create a type alias specifically for that, where you just have to pass the type parameter that you're expecting, but everything else is kind of implied by the name of the type alias. Right. So to summarize then, so the result monad for us has been a fantastic tool for modeling expected control flow. It enables a railway-oriented programming style, which has been hugely successful for us, and it makes it super easy to make clear your intentions and to allow people to handle this in an appropriate way if they want to. It is absolutely not a catch-all, and you really don't want to go around wrapping everything. So do avoid doing that. And you still ultimately have to consume third-party APIs really diligently. So you don't get any help in terms of knowing whether something can throw. So therefore you have to wrap it. And I would argue that you don't necessarily want to do that in a lot of places either. So there is a balance there to be struck, which is up to you. And like I said, result is not always appropriate. There's definitely cases where it's going to be better to just straight up throw. And that's it. Thank you very much. Hopefully I've given you some ideas about how you can use some functional error handling in your project and how that can kind of simplify things and make your lives a little bit easier. Feedback is very much appreciated, so feel free to ping me on Twitter or jump on one of these tables in a few minutes and give me some feedback. It's very much appreciated, and I'm more than happy to hang around and answer some questions a little bit later. If that piqued your interest, but you want a little bit more in depth, please do check out my website as well, adambennett.dev, and you can dig into that there. Yeah, it's a really good question. I think, to be honest, the kind of, I would argue it's possibly slightly less ceremony than the whole try-catch kind of construct. And certainly it can handle more situations and it's more flexible in terms of how you choose to consume that. So for us, we didn't really see it as too much ceremony in that respect. In some ways, it kind of potentially cut it down a little bit. So we didn't really see much in the way of pain points there. Yeah, so this is something that I addressed in my blog a little bit, because it's actually an approach that we took initially. And one of the issues with this is you end up with a kind of sealed class explosion, and you don't get the kind of, so critically you don't get the monadic chaining. So when you want to convert between types, as we do pretty frequently, if you're converting, say, from data to domain to presentation, what you end up doing is, because it's a sealed class, you're forced to handle both types. And it means whether you want to or not, you have to do a when statement where you then do some kind of mapping. And you have to do that at every level. And the benefit of the result monad is you can choose to map just the success type or just the error type. You don't have to do this whole when this type or when that type. You can delay that to the very last second if you want to. And that for us was a huge advantage. Yeah, and also it's, if you make them say per use case as well, if you have these sealed classes per use case, which is what we totally tried, yeah, you just end up with hundreds of them. And because, unless you're very, very strict about, say, naming conventions for them, finding the one that you want is really annoying as well. So we ended up discarding that. We got rid of that in the end. It was kind of a happy accident, actually. So MVI, initially, I think when I joined Cuvva, we didn't want to go the MVI route. And I've written before about MVI, about how there's quite a lot of boilerplate. And how the onboarding process can be quite steep because it does rely on a lot of functional programming concepts. However, we wanted to be absolutely prepared for when Jetpack Compose comes out, and we use a lot of custom view components. And so it made sense to us to model these custom UI components with view states, and the idea being that you use MVI to construct a view state made of smaller sub-view states for specific views. And this is very compatible with Jetpack Compose, and we think that when Compose becomes a production thing, it will make that transition really easy. But at the same time, we were looking for some kind of solution for this kind of, not so much the try-catch. By this time, we'd moved to the individual sealed classes for every operation. And we were looking for some kind of more generic solution for that. And the two just happened to kind of meet in the middle and work really, really nicely together. So yeah, I hope that answers that. So, I mean, you could go this route. The downside is you have to write this monad yourself. So you'd have a map error and a map loading, for instance. But generally, you're very unlikely to need to map between loading types, for instance. We didn't really being a tech startup where there's only 3 of us on the team, we've got a lot to do. We didn't necessarily want to kind of build one of these monads from scratch because they are relatively complex, a lot of generics and that kind of thing. But also, like I said, we kind of decided that the layers that would where we'd want to model our logic using one of these result monads, it's kind of not its job to inform you whether something is loading or not. What we decided instead is the presentation layer says, okay, I'm loading, and then goes to fetch something and then handles that result afterwards. Yeah, that is just a design decision that we made, but also a pragmatic one because we didn't want to kind of reinvent the wheel. So I vaguely recognized that name. We did evaluate a whole bunch, and ultimately the one that we chose, we just thought was the best maintained one. It's got a huge suite of tests. Kotlin multi-platform is coming, which is really, really good. The developer's very responsive, and like I said, it borrows a lot of functions from different languages, which meant there was some familiarity there. And what we liked as well is that you have a couple of different ways to do different things as well. So depending on what you're more comfortable with, you can chain these using the and then function or the flat map function. If you're coming from RX Java, flat map, so they do the same thing ultimately. Flat map will be more familiar to people who are very RX heavy, and then is far simpler to parse mentally if you're just getting getting into the style of working. So yeah, we just thought it was the more complete solution for the most part. Yeah, that is a fantastic question because we spent a fair bit of time looking at Arrow as well and evaluating whether it was something we wanted to go with. And ultimately, it's going to be about your needs and what you're comfortable with. For us, just integrating result was enough to satisfy pretty much all of our needs without having to go much further. Obviously, Arrow adds a ton of extra stuff, and a lot of it is fantastic. But no one on the team, I don't think, would claim to be a true functional programmer, and we didn't want to go a completely functional route. It's already pretty difficult to hire good Android devs, and having to exclude people who aren't really up to date with functional programming is just not something we really wanted to do. We felt like we could onboard people to using a result and switching between success and failure, but using some of the more complex constructs like things like optics, things like validated and stuff like that, they're kind of awesome, but probably a step too far for us, basically. So it's going to be up to you. It depends what you're comfortable with and what problems you're trying to solve. You don't necessarily want to go the whole hog. And I think I wouldn't necessarily recommend going the whole hog on Android as well. But I'm also not a pure functional programmer.